Hola, mi clase. Today we are doing 9.5 congruent figures. So we're going to make connections between our transformations. So our rotations, our reflections, and our translations, and shapes that are congruent, okay? So the word congruent means that it's the same shape, same size, everything about it is the same, except maybe it's in a different spot. So it's like being equal in an equation, but the reason we use the word congruent instead of equal is because they're just the same shape and the same size in a different location. So that's the word congruent is used more for shapes, but it basically means that everything about them is equal, they're just in a different place. Okay? So we're going to combine transformations. We're going to apply the indicated series of transformations to the triangle in this grid. Each transformation is applied to the image of the previous transformation, not the original. Label each image with the letter of the transformed applied. So that's what that means is we're going to do transform by reflecting across the x-axis to here, and then we're going to label it A. Okay, so let's do that first. So the x-axis is this one. Remember, it needs to be the same distance. So if it's 2 away, it's going to become 2 away. If it's 1, 2, 3, 4 away, it's going to be 4 away. And this one's also 4 away, but lined up here, 1, 2, 3, 4. Okay, and then I'm going to connect my dots. And what I'm going to do is label this A. It's not a very good A, but that's what I'm going to do. So there's A. Now that we're done with A, I'm going to apply letter B to letter A. That's what it means. So now it looks like I'm going to subtract 3 from all of my x's. That is a translation, right? So we're just going to subtract 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And we're going to label this B. Okay, B's done. Now I'm going to take C and apply it to B. Okay, so we're getting the idea. Every one is done to the one before it, not to the original. So we're just kind of slowly moving it around. It's very similar to the Desmos activity that we did, where you had to do one, take that, move it again, maybe flip that. That's what we're doing, okay? So we're going to reflect now over the y-axis. That's this one right here. Well, that means this point's not going to move because it's 0 away from the y-axis, so it's going to stay 0 away. This one's 2, so we're going to go 1, 2. And this one's also 2, so we're going to go 1, 2. And then we're going to reconnect, and this one's going to get called C. All right, C's done. B, we're going to add 4 to the y. That means we're going to go up 4. All right, up 4. That's what that means. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. And that's letter D. All right, letter F says we're going to rotate 90 degrees clockwise. So clockwise is this way, about the origin. So since this one's on the origin, it is not going to move, okay? Remember, our rule for clockwise is that they get switched and the x's change to their opposites. So if this is at 0, 2, it's going to become, negative 2, 0. This is negative 2, 0. It's going to become 0, positive 2. So it's going to go here. And then this point's at negative 2, 2. So it's going to become 2, 2. And I know we don't actually have letters for these, right? Like A goes to B prime, C prime. So it might help if later that you do this as well, just so that you can get your points where they belong. So there's E, all right, and then we're done. So the only thing left is to answer letter F. It says compare the size and the shape of the final image to that of the original figure. Well, this was the original. This is now our shape after all of these different transformations. It wants us to compare the size and the shape. Well, if we look, it was 2 across the side, 2 across the side. If we check, it's still a 2 across and 2 across. Diagonally, it's kind of hard to count. I mean, we can kind of say maybe two-ish across. Well, we can see it's 2-ish across there. So the size is the same. And then the shape, it's still a triangle, and it's still an isosceles triangle. That means two sides are the same. So we would say the shape is the same. So since we have size is the same and shape is the same, we can actually say they are congruent. And I'm going to write a weird sentence down here. There we go. Because that's our definition. So even though we did all of these transformations, what we're trying to realize is that even if I reflect, translate, rotate, none of those are going to change. So if I do any of these transformations that we've worked on, reflection, rotation, translation, it's not going to do anything to the size and the shape. They're going to always be congruent, or at least they should be, which we've talked about in 9.1, 9.2, and 9.3, and every day that we've done this. The shape should be identical, just somewhere else on the grid. They are congruent. Everything we've done so far is congruence. Things should stay the same size and shape. All right, so it says identify the sequence of transformations that will transform A to become B. Okay, so blue to green. This is, again, very similar to your Desmos activity. We just need to figure out what did I do to A to make it become B. Well, we can see that it clearly has been flipped, right? The right now has become the left, and the left has now become the right. That is clearly a reflection. It looks like it's possibly a reflection over the y-axis, right? So let's start there. Let's reflect it over the y-axis. So that means I'm going to take x, y, and I'm going to switch my x's. Okay, I like to always start with the one that I know for sure. It's clearly been reflected. I want to start there. So this one's 1 away, so 1 away, 2 away, 1, 2. Maybe connect them as I, ooh, that was really bad. Connect them as I go so that I don't lose track of where I am. 1, 2, 3, 1, 2, 3. So this one looks like 1, 2, 3, 4, 1, 2, 3, 4, but it's up here. This one's also 4, but down here 1, and it looks like I'm done. There we go. There's all my points. All right, so there's my reflection over the y-axis. Well, now we can see that I clearly need to just slide it over 1. That's a translation. And we're going to say 1 to the left. So that's, now we're going to take our x, y, and we're going to take x and minus 1 because that's all I need to do. And so if we look, 1 over, 1 over, they all end up where they're supposed to be. All right, there we go. So we only needed 2. Sometimes we need 3. Sometimes we need 4. It just depends on the transformation. All right, so this is problem number 1. This is separate from down here, okay, if you want to label them to see the difference. Okay, there's like a line right here. All right, so this says identify the sequence of transformations that will transform B into figure C. So we're going B to C. Well, I'm going to just start this one out for you and kind of give you a hint, but you're going to have to find the rest of it, okay? So what I would do first is I would do a rotation. You can see that it's clearly turned. So I would start with a rotation, and it's going to be only one time, one quadrant, okay? So that's 90 degrees, and that would be counter. That's where I'm gonna start. I'm gonna have you do that, figure out where it is, and then I want you to find out the second sequence, okay? That's as far as I'm going. You're gonna finish this. I wanna see it finish. It's gonna be an expectation of your notes being completed. All right, so here's the second problem. It says if point A is at -4, 4, and point G is at -1, 4, and they are both rotated 90 degrees counterclockwise, similar to this, and translated 6 down, what's the length of line segment F prime, G prime after the rotation and after the translation? Okay, well, here's what we just talked about at the beginning. A rotation and a translation will keep everything congruent, right? Nothing about the lengths or the angles or anything about it is going to change. So like if I look here, let's just use this as an example. From this point to this point, it's 1, 2, 3. We're going to do a sequence of a rotation and maybe something else. But if I look, it's still 1, 2, 3. So if the question asks something like this, you actually don't need to go and counterclockwise it and translate it. We just need to find the length between F and G, and that'll tell us the length of F and G prime, because a rotation and a translation keep everything congruent. So all I have to go do is figure out how far apart F and G are. So if I graph 1, 2, 3, 4 and graph 1, 2, 3, 4, here's F. And then I go graph G, it's a -1, 4, here's G. I just need to find out how far apart they are. 1, 2, 3. They're 3 units apart. So guess what? F prime G prime is 3 units. Oops, I didn't even spell units right. Units as well. Done. I don't have to rotate, I don't have to translate, because we just saw at the very beginning I can do as many, the very first problem we did, right? We can do as many as we want. A rotation and a translation will not change the size. So if it's 3 units in the beginning, it's 3 units in the end. That's it. I don't have to do anything else. Okay, so the main thing I want you to remember is that translations, rotations, and reflections will not, I'm going to capitalize this, will not change the shape or size. Oops, size. All right, I'm going to make that a little smaller. That way you guys can see it too. There we go. Oops. There you go. Main thing is that it will not change the shape or the size. Okay, so remember we talked about this a couple times. If it's 3 units, it'll be 3 units. If it's 4 units, it'll be 4 units. I've talked about that when we were doing 9-1, 9-2, and 9-3. Okay, so on your independent practice, you're going to practice doing a sequence. It says imply the indicated series of transformations to the rectangle. Each transformation is applied to the image of the previous. This is just like example 1, not to the original. Label each image with letter of the transformation applied. So it's just like that first example we did. I'm going to apply A to this. I'm then going to apply B to A. And then I'm going to apply C to B, and D to C, and E to D. Okay? That's how you're going to do it, just like the first example. All right, until next time, adios.